is our next example. If we have r raised to the r times r raised to the power of 0 times r raised to the power of 5, how are we going to solve it? Now observe, they are all having the same base, r. So just law of indices, pick one of the base, then add their power. This one is not having, this one is just add. We can decide to put one here, introduce one as the power. It's the same thing, r raised to the power of 1 and r, they are the same thing. So if you want to add this base, it will be the powers, it will be 1 plus this 0, then minus this 5. So this is equals to r raised to the power of 1, 0 minus 5. So this is equals to r raised to the power of 1 minus 5 is what is minus 4. So it brings us to this place. But we cannot leave our answer like this because the law of indices, the other law of indices told us that if we have something like this, we should make it 1 over r raised to the power of 4. This is the solution. Alright. Okay, let's solve 24 x raised to the power of 6 divided by 8x raised to the power of 4. If this is what you are having, this is actually 24x raised to the power of 6 divided by 8x raised to the power of 4. Observe, these constants, they can cancel each other. 8 here, 1. 8 in 24, that's 3. So we are left with what? 3x raised to the power of 6 over x raised to the power of 4. Now, we can rewrite this as 3x raised to the power of 6 divided by x raised to the power of what? Of 4. So that we can use what? The second law of indices. So this is equal to 3. This is a constant. So we pick one of the base since they are the same. This is x. Then add minus their power since this is linked together by minus. So this will be what? 6 minus 4. We have this to be equal to 3x raised to the power of what? Raised to the power of 2. Do you understand that? Alright. Now, if we have this example, say 1 over 4 raised to the power of what? Of minus 2. Now, let's solve this. To solve this, we first of all deal with what is inside the bracket, then we'll talk about the negative power minus 2. Now, 1 minus 4, we know that this is equals to what? This is equals to minus 3 raised to the power of what? Minus 2. Now, I told you guys something about solving indices with negative power the other time. I said solving this with negative power makes the question more complicated. So as such, we don't need this negative. All our aim is how we can eliminate that negative. Now to eliminate this negative, this minus 3, we make it a fraction. If we want to make this thing a fraction, it's the same thing as saying 3 over 1. We have not changed anything. 3 over 1 is the same thing as 3. Now we are now having it in fraction from raised to the power of minus 2. Now if we swap, if we carry this one up and this 3 down, we have swapped automatically. So that by doing that, the minus is gone. So this is equals to minus 1 over 3 raised to the power of what? Raised to the power of 2. Mind you, the 2 belongs to what is in the numerator and what is in the denominator. Now this is equals to, and even the minus, the 2 belongs to everybody. So now, if I raise 1 to the power of 2, this is equals to minus 1 raised to the power of 2 over minus 3 raised to the power of 2. This is what this implies. So 1 square is the same thing as 1. Then minus 1 square is the same thing as 1. While minus 3 square is the same thing as 9. So automatically, this is what we are having. You understand? Alright, this is our next example. It says we should solve 3x raised to the power of minus 3. Now, whenever you see something in the bracket and is raised to the power of another number, it means that this minus 3 is for everything inside the bracket, both the 3 and the x. So if we want to split the minus 3 for everything inside the bracket, we are going to have, this is equals to 3 raised to the power of minus 3 multiplied by x raised to the power of minus 3. We have given the minus 3 to everybody inside the bracket. Alright. According to the law of indices, it said if we have something like this, it should be what? 1 over what? 3 raised to the power of 3 multiplied by this one is what? 1 over x raised to the power of 3. We have spoken about this law before. Alright. If if I have this is what I'm going to have. I'm going to multiply the numerator, then the denominator. So I'll now have 1 times 1, I'll have 1 over 3 raised to the power of 3 times x raised to the power of what, of 3. This is equals to 1 over 3 raised to the power of 3 is what, 27. That is 3 times 3 times 3. 3 times 3, 9 times 3, 27. So we have 27 times x raised to the power of 3. So this is equals to what? 1 over 27x raised to the power of 3. Our next example, 9a raised to the power of minus 5 times 4a raised to the power of 6. Alright, now I'm going to multiply these two constants together first, then solve this one using the law of indices. 9 times 4, I'll have what? I'll have 36. So this is my constant. I'll have 36. So this is my constant. Now this is a raised to the power of minus 5. This is a raised to the power of minus 6. They're both having the same base. So I'm picking one of the a's. Then I'm adding the power since it's what? I'm having multiplication here. So I'll have minus 5 plus 6. So this is equals to 36a raised to the power of what? 1. 5 minus 5 plus 6 is 1. So I'm having what? 36a. This is what I'm having. These are the questions I'm asked to simplify. If I have 9 raised to the power of 1 over 2, I can decide to write this 9 in index form. Now, my target is my numerator, the denominator of my power. The denominator of my power is my target. Now, what can I raise to the power of what is in my denominator to have this whole number here? That's what should be your target. In this case, what number will I raise to the power of this denominator to get this whole number here? In this case, what number will I raise to the power of the denominator to get this whole number here? That's your first question. Now in this case we are having 9. Which number will I raise to the power of the denominator? The denominator here is 2. What number will I raise to the power of the denominator to get 9? The answer is 3. Now if I raise 3 to the power of 2, I'm going to get 9. I have not changed anything. This 3 raised to the power of 2 is still the same thing as this 9. Then I will raise to the power of what? Times this raised to the power of 1 over 2. I've been able to simplify this to this form. Now, these two can cancel these two, right? So I'm left with what? I'm left with 3. So this is the solution to the first one. Now the second one says 8 raised to the power of 1 over 3. Now I've told you the first thing that you consider when you have something like this is this denominator. Which number can you raise to the power of the value of this denominator to get this whole number? This is 3. Which number can I raise to the power of 3 to get 8? I can actually raise 2 to the power of 3 to give me what? To give me 8. 2 raised to the power of 3 is 8. So I'll substitute 2 raised to the power of 3 for this 8. Then times this raised to the power of what? 1 over 3. So 3 can cancel 3. I'm left with what? I'm left with 2. Alright. The other one, the example 3 says what? 8 raised to the power of what? Of minus 2 over 3. Now the same thing you do. Which number can I raise to the power of 3 to get 8 as this whole number? 2. If I raise 2 to the power of 3 is equals to 8, then times minus this what? Minus this 2 over 3. So this 3 can cancel 3. I'm not left with what? 2 raised to the power of minus 2. And law of indices tells us if you have this, it should be equals to what? 1 over 2 raised to the power of 2. This is equals to 1 over